Halo, jumpa lagi di persiapan Matematika ASEAN Scholarship. Kali ini untuk entry level secondary 3. Pada video ini akan dibahas contoh soal secondary 1 Singapura yang diambil dari ujian akhir tahun 2021 Anglo-Chinese School Barker Road. Soal-soal ini diambil dari website studykaki.com. Selamat menyaksikan.
Hello everyone, welcome back. Today we'll be looking at secondary 1 mathematics, and we're going to be looking at 5 questions as per usual. And let's begin with the first one. So let's begin with the first question as question 2 right here. And before we go into question 2, I want to introduce this term called significant figure, which is a very common term used in Singapore examinations. And what it essentially means is the number of digits we want to leave out for the number. So let's say we have the number 1.2345, and we want to leave this number as, let's say, 3 significant figure. So SF stands for significant figure. And what this means is we want to convert this into just the first 3 digits rounded accordingly. So it should be 1.23. So we don't need to care about the last 2 digits because we just want the first 3 significant figures. And if, let's say, we want to round it to 4 significant figures, we want to make it into 1.235 because we round up when it's 5 or above. So this 4 is rounded up to 5. And let's see what the question is asking. The question is saying that we need to round up each number to 1 significant figure and estimate the value of this equation. So let's do that. So we have 3 numbers right here, 62.89, 8.93, and 3.12. We're going to round each of them into 1 significant figure. 62.89 becomes 60, and 8.93 becomes 9, while 3.12 becomes 3. So this becomes equals to 540 divided by 3, which is equals to 180. So now let's take a look at the second question, which is question 7 here. And this is a little bit about geometry, specifically parallelogram. So we have parallelogram ABCD, where we have BE is perpendicular to AD, meaning that there's a right angle in between these two sides, and BF is parallel to CD. So how we can solve this question is we use the formula of the area of parallelogram, which the area is equals to base times height. And we can use AD as the base and BE as the height, because B is perpendicular to the base, which is AD. So AD would be equals to 7 because its parallelogram has 2 pairs of equal sides, AD and BC, as well as AB and CD. So this must be 5 as well. So to get the area is simply 7 times 4 because BE is 4 centimeters, so this gives us 28 centimeters squared. And we also know that CD can actually also be used as the base with the corresponding height as BF. So we also know that 5 times BF is equals to 28. And that gives us BF as 5.6 centimeters. And now we're actually going to move on to a completely different question. So this question has 4 parts, and it will be talking about prime factors and how we can use them to solve different things. So firstly, we want to express 90 as a product of its prime factors. And of course, there's multiple ways to do this. One is you do the splitting, branching method, whatever you call it, where you basically try to divide by the primes as small as possible in the left side and until you reach a prime number on the right side. So you'll have 2, 3, 3, 5, meaning that 90 is equals to 2 times 3 squared times 5. And now we want to find the lowest common multiple of 90 and 156. So I'm just going to write this here, that 90 is equals to 2 times 3 squared times 5. while 156 is equals to 2 squared times 3 times 13. And just to recap how we're supposed to find the lowest common multiple using product of prime factors is we use the largest power for each factor, for each prime factor. So for example, for the prime 2, we have 156 as 2 squared, which is larger than 2 to the power of 1. And for 3, we use 3 squared because 3 squared is larger than 3. So the LCM would actually be equals to 2 squared times 3 squared times 5 times 13. And this should be 2,340. And for part C, we have the number 156 over k is a perfect square, and find k. And we can also use the product of prime factors we used earlier. And we know that that the number 156 over k is a perfect square. So that means each exponent of the prime factors must be even. So for example, 3 cannot be the prime factor because cannot be one of the prime factors because currently it's 3 to the power of 1, which is odd. So what we can do is we want to remove all the prime factors that has the power 1. So we want k to be equals to 3 times 13, which is just 39. And you can see here that if we do divide by 39, we can cancel out this 3 and 13, leaving us with a perfect square. Now for the last part, we're actually going to take a look at highest common factor. And the highest common factor is sort of the opposite of lowest common multiple in part B. So for part B, how we found the lowest common multiple is by finding the higher power for each prime factor. But for highest common factor, we actually want the smaller power, and it must be common in both of these numbers. So for example, 2 is one common prime factor, but 13 is not a common prime factor because it is only inside 156 prime factors. So we have the highest common factor of 156, and x is 26, and x is between 100 and 200. So firstly, we know for sure that x is a multiple of 26 because 26 is a factor. And what's next is we can also write the prime factorization. So 2 squared times 3 times 13, and x is equals to 2 times something something times 13. So we don't know what's inside here, but we know for sure that x actually has prime factor of 2 and 13 because its common factor is 26. So we also know for sure that inside x prime factor, this must be to the power of 1 and not anything larger, because if it's anything larger, then the common factor would be more than 26. For example, if this is 2 squared, then the common factor would be 2 squared times 13. Same goes if this is to the power of 3, it would be 2 squared times 13. So we know for sure it's to the power of 1. And what's next is we can actually do trial and error, where we have 26 is 26 times 1, and 52 is 26 times 2, and so on. And we realize that the first number that is in between 100 and 200 is actually 104. And however, we realize that 104 is not valid because if you try to prime factorize it, it'll be 2 squared times 13. So as we mentioned earlier, it cannot be the case. So the first valid x is actually 130. Now for question 4, we're going to look at this angle question, and let's revise a bit on what the question is asking. So we have JABCD, which shows a part of a regular 10-sided polygon. So what this means is that each side is of equal length, and each angle in between these sides are of equal length as well. And we can actually use the formula that the sum of all of these angles would be equals to 180 times n minus 2, where n is the number of sides in the polygon. So in this case, n is equals to 10, so it's 180 times 8. And that's the sum of the angles, so this will be equals to 1,440. And we also know that there's 10 of these angles that make up 1,440. So each angle is 1440 divided by 10. So this is the sum of angles, and each angle is equals to 144, which is 1440 divided by 10. This is degrees and this is degrees. And for part 2, angle AOJ is actually this one right here. And we know that since it's always the center, eventually I have all of these. And actually all of this would add up to 360. And we know that there's 10 of these angles. So angle AOJ is 360 divided by 10, which is just 36 degrees. And we also have angle CAJ, which is a bit more difficult, CAJ. And we can find this angle by first finding what BAC is. We know that this is equals to this. AB is equals to BC, which makes ABC an isosceles triangle. That means angle BAC would actually be equals to 180 minus angle ABC, which is 144 divided by 2. So this would give us 18 degrees. So angle CAJ would just be equals to 144 degrees minus 18, which gives us 126 degrees. And for our last question, we're actually going to take a look at this contextual question, question 9, which is the last question of this paper. So let's try to understand what this question is asking. So in this question, we have Jeremy, who owns a car of engine capacity 1,599 cc. And he drives on average about 11,000 kilometers per year, and his car travels 11 kilometers on every liter of petrol. So we need to first identify how we can calculate the amount that Jeremy pays for petrol in a year. And we want to know what information do we need to calculate this amount. So if we try to read the question, we know some information. We know what capacity his engine is, and we know how far he goes and how much kilometers can 1 liter use. And we also have a bunch of costs here. And to calculate the amount, we actually need to find out how many liters, amount of petrol used in liters, multiplied by the cost per liter. And we actually know what this is because the engine capacity is 1,599 cc, which categorizes it over here. So I actually know this as $2.49. So now what we need to find is the amount of petrol used. That's actually also quite simple because he travels 11,000 kilometers on average per year and 11 kilometers per liter. So that means the amount is 11,000 divided by 11, and you multiply it by the cost, which is 2.49. So this gives us $2,490. Now for part B, we have some extra information here. So in addition to petrol, Jeremy estimates that he will have to pay some other things. So we have these car insurance, electronic road pricing, and so on. And Jeremy estimates that if he didn't have a car, he would need to pay for these monthly travel costs from taking public transport. And the question is asking which one is cheaper. So the way to do this question is we want to calculate the total costs for each of them. So for car, we would have our original petrol amount, which is 2,490. So car is 2,490 added with 1,650 with a 40% discount because of this no claim discount right here. So 1,650 multiplied by 0.6 plus 920 plus 2,000, and finally plus 2,640. So this would add up to 9,040, I believe. And now we need to calculate the costs for public transport. So public transport would be equals to the total of MRT, bus, and taxis multiplied by 12. So this would be equals to 480 times 12. So that's equals to 4,800 plus 960, which is 5,760, I believe. And so we can clearly see that car is more expensive than public transport, which is also the case in the real world, because in Singapore, cars are actually quite expensive.